Section 8.1 is on adding and subtracting polynomials. Before we talk about polynomials, we will talk about monomials. So a monomial, the prefix mono means one, so a monomial is a real number, variable, or product of a real number and one or more variables with whole number exponents. So here are some examples. So if we have just a constant like 18, that's a monomial. And basically what we're doing with a monomial, we're thinking about it that it's just got one term. If it's one term, in other words, if there's no addition or subtraction, then it's going to be a monomial. So 18, just a constant like that would be a monomial, just one term. Z, if you have just a variable, that's a monomial, one term. Negative 4x squared, we've got a coefficient next to that, but that's also just one term. We could even have something like 2.5xy cubed. Technically, as long as they're right next to each other, as long as they're just being multiplied together, I mean, you could have the whole alphabet next to, have a number and then the whole alphabet behind it, even with exponents, as long as they're whole number exponents. We don't want to have, like to the 1/2 power. We don't want like square roots and stuff like that. But and then a over 3, that's another example if something's just being divided, because we know also we could write that as like 1/3 a. Okay, so these are all examples of monomials. So we can talk about the degree of a monomial, and we find the degree of a monomial by finding the sum of the exponents of the variables. So, for example, if we have 5 to the x power, we know that we could write that to the first power, so that's degree 1. 6x cubed y squared, if you add the exponents there, 3 plus 2 is 5, so degree 5. If you look at the 4, like the book mentions here, this we could say it's the same as 4x to the 0 power. We probably wouldn't normally put x to the 0 power there, but anyway, notice the exponent then is 0. Remember, x to the 0 power would be equal to 1. So if you look at the got it questions, we're mainly just going to look at ones like part C and things that have one variable. So I'm going to actually, let me just modify these just to get some more practice with this. So let's say we have 8x cubed. So 8x cubed, what's the degree? That would be degree 3 because the exponent is 3. Let's say we've got negative 3x squared. That would be degree 2 because that's to the second power. And then 11 we talked about, if it doesn't have a variable there, that would be considered degree 0. So we can add or subtract monomials if they're like terms. So if you look at problem 2, part A, 3x squared plus 5x squared is equal to 8x squared. Okay, just like 3x plus 5x equals 8x, just like 3 plus 5 equals 8. It's the same idea. We don't know what x squared is, so that's all we can do with it, but we could condense it down then into a monomial 8x squared. Another example, we've got 4x cubed y minus x cubed y. The x cubed y, you could put a 1 in front of that, and then if you subtract, that would be 3x cubed y. Again, in order to combine these, the variable parts have to be identical to each other. So if we look at the got it question, they want us to find the sum of negative 6x to the 4th plus 11x to the 4th. So just like as if we're adding negative 6 plus 11, and then the x to the 4th just comes behind it. So negative 6 plus 11 would be 5, so this would be 5x to the 4th. And then the next question, what's the difference of these? So finding the difference, just like we did with subtracting integers, if you want to add the opposite, you can. So this is kind of like 2 plus negative 7 would be negative 5 x squared y to the fourth. Since those variable parts are identical, they're like terms, and we're able to combine them together. We can also talk about polynomials. Polynomial, technically it says, is a monomial or a sum of monomials. To me, if we only have one term, I'm just going to call that a monomial. So I'm going to think of a polynomial as a sum of monomials. So if we have several monomials being added together, that's called a polynomial. Poly means more than one. So this would be an example of a polynomial. And in a polynomial, we can talk about also then what the degree of each of those terms are. So 3x to the fourth would be degree 4. 5x squared is degree 2, minus 7x is degree 1, and then plus 1 is degree 0. And then what we can do then is we can name a polynomial based on the highest degree that we see. So the highest degree in this case would be degree 4, so this would be a fourth degree polynomial. In order to make it easier for us to figure out what degree it is, and just to make it easier that we're all putting our answers the same way, normally we're going to write our answers in standard form. So standard form is where the degrees decrease from left to right. In other words, we start with our highest exponents and we work our way down. And I already mentioned the degree of a polynomial is the greatest exponent that we see if there's only one variable, which is what we're going to be working with. Okay, so whatever the degree of the monomial with the greatest exponent. So here's some examples of different things. We have first 6. To me is really just a monomial, but whatever. That's degree 0. We could call that a constant. It has one term, so it's a monomial. 5x plus 9, since we have the x here, that's like 5x to the first power, so that's degree 1. And that we could call linear, and that's got 2 terms, and it's a binomial because it's got 2 terms. Binomial, bi means 2, like a bicycle has 2 wheels. 4x squared plus 7x plus 3 is degree 2 because we have an exponent of 2 as our highest exponent here. That can be called a quadratic. We'll talk more about later as we go through the year. That has 3 terms, and that is called a trinomial. Trinomial, 3 terms. 2x cubed is degree 3. That we can call cubic. It has 1 term, and that is a monomial. And 8x to the fourth minus 2x cubed plus 3x, that's degree 4. So fourth degree has 3 terms, and that also is called a trinomial. So if we look at these then, I mentioned this, but just to make sure everybody caught this, a binomial has 2 terms. A trinomial has 3 terms. If it's more than that, we don't really normally use special names. We just call them all polynomials if there's more than 3 terms. And then we can also talk about what the highest degree is and what we can call these. So the highest degree, and then we could say the name using the degree. So if the highest degree is 0, that would mean we just have a constant. So we'll just call that a constant. If the highest degree is 1, that's linear. Kind of like we've talked about linear equations, like y equals 5x or something like that is a linear equation. It makes a straight line. Highest degree is 2. That's called a quadratic. And we'll be talking about quadratic equations. Quadratic equations which make they kind of look like either a U shape or an upside down U. They're called a parabola. Degree 3 is called a cubic equation. Okay, cubic, like the third degree, like a cube has 3 dimensions. Beyond that, we don't have special names. So if we have 4, that's just called the 4th degree. If we have something with the 5th degree, that we just call it 5th degree. And with quadratic being 2, initially when I looked at this, then it was kind of like, well, why is that the case? Because I've heard of like quad as a prefix having to do with 4, like 4 quarters in a dollar, and things like that. Or like sometimes if they say quad is like 4, so like your quadriceps I think is like 4 different muscles. Anyway, in Latin, probably none of you take Latin, but anyway, in Latin there is quadri or quadri, I'm not sure how you pronounce it, means 4. Quadratus means squared. So this is coming from Latin. Quadratic is coming from the Latin quadratus, which means squared. So if we knew Latin, then this would make perfect sense. It'd be like, oh yeah, quadratic, yeah, that's squared. It's to the 2nd power. No big deal. So problem 3, they want us to classify these polynomials. So first write them in standard form and then tell what the name of them is based on the degree and the number of terms. So for part A, we're going to rearrange that as 4x squared plus 3x. That's in standard form. And then since we have a 2nd power is our highest, then that's called quadratic. And then since there are 2 terms, then it's called a binomial. So this is a quadratic binomial. Part B, rearrange. Highest exponent is to the 3rd power, so we'll start with that one and then just work our way down. Make sure that the sign to the left stays with the terms whenever you rearrange them. And then one thing kind of different on this problem is that we actually have like terms here that we can combine. So we could combine those together, and that gives us 5x cubed plus 11x minus 1. So that is our standard form. So by combining those, now we have less terms. So first of all, this is to the 3rd power is our highest power, highest exponent on the variable. So that makes it cubic 3rd power. Okay, just like something's to the 3rd power, it's cubed. And then by combining, now we actually only have 3 terms. So this is now a trinomial. So if you look at the Got It 3 Part A, we can do some rearranging there. So we could rearrange that would be 8x squared plus 2x minus 3. And then if you look at your highest exponent is 2, which means this is quadratic. And then we have 3 terms, which means it's a trinomial. So quadratic trinomial. You can add polynomials together just by adding like terms. So if you look at problem 4, researchers studied the number of overnight stays in U.S. National Park Service campgrounds and in backcountry of National Park System over a 5-year period. Research modeled the results in thousands with the following polynomials. And we make sure we remember this is in thousands, makes a big difference. So here you can see campgrounds and backcountry. And then it says in each polynomial x equals 0 corresponds to the first year in the 5-year period. What polynomial models the total number of overnight stays in both campgrounds and backcountry? Okay, so the total number would be, we would be adding them together. So there's different ways you can do this. One option the book's mentioning is adding these vertically. To add them vertically, you want to line up your like terms. If there's something that gets skipped, you could put a 0. Like if there was no x term, you could say like plus 0x. As it is, we have x squared, x, and constant on both of these, so it's not a big deal to line these up. And then we're just combining like terms. So if we combine these together, negative 7.1x squared plus 21x squared would be 13.9x squared. Different signs, so we're subtracting those. And we could do it by hand if we need to, but and then when you combine your x terms, that would be minus 320x. And then the constants would be plus 7,700. So that's one way of doing this. Another option is adding horizontally. What the book did is they just rearranged these. And it's up to you. I would suggest you could even do this with a third option, which is just add horizontally without rearranging. Just make sure you watch that this is adding here in between. And then, you could just kind of even use different colors or like underlining, circling, boxing things in to help you make sure that you're actually combining the like terms together. Okay, so that would be our polynomial that models this. So if you look at the got it 4, similar idea, we're talking about consumption of carrots and celery and broccoli. I'm sure this is your normal topic of conversation, but anyway, for nutritionists. So you can see the polynomials for carrots and celery, and then a separate one for broccoli. X equals 0 is for the first year in their 6-year period. What polynomial models the total number of pounds in millions of carrots, celery, and broccoli consumed in the United States during the 6-year period? Okay, so what we're doing here, we're just going to be combining these like terms together. And I guess I'm going to go ahead and just add them vertically this time, just because that's easier to show you and have all this on the screen at the same time. So with broccoli, there was no x cubed term, so we just skip over the x cubed part. It's not in the middle, so we don't have to put a 0 there, although if you want to put a 0 there, you can. So we add these together. And this should be your answer. Problem 5 is on subtracting polynomials. With subtracting polynomials, you can add the opposite. And I kind of prefer that method actually, which is more like method 2 in your book. I'm going to show you just a slight variation of method 2 in your book, I guess, here. So if you're subtracting, method 1, the book's kind of just remembering, oh yeah, I need to subtract these numbers. That's a little haphazard if you ask me. So I'm just going to add the opposite, opposite, opposite. We'll just do the opposites of all the things inside the parentheses, what we're subtracting. It's really just like multiplying by -1. Like if you had, let's say, just make it simple. Let's just say you had -5. Normally we wouldn't do this, but you could put a 1 here. So this would be like -1 times 5, which would be -5. It's kind of like distributing a -1. When you distribute a -1 to all these terms in the parentheses, then it just changes their signs. And then once we've done that, then it's just combining like terms. So now we can combine these together. combine your x cubes together, combine your x squareds together, and there's actually only one x term here and only one constant, so those don't get combined at all. Okay, and if you had, instead of minus 8x squared, if you had plus negative 8x squared, that would work also. Okay, so if we look at this, they got it 5. They want a simpler form of this, so they want us to try to combine these together. So once again, I'm just going to add the opposites here. You can put a 1 in front of the m if you want, and then I'm just going to work this out in how it's written rather than rewriting it. So we have an m cubed, we've got m squared, we've got m, so that would be like minus 2m, and then constants we can also combine. So if we look at the lesson check, number 1, they want the degree of that monomial. Rewrite it here, it's a little curved, but that would be to the 4th degree. The next part, they want us to simplify these. So if you simplify on number 3, just combine your r cubed terms together. That would be 11r cubed plus 11. Number 4, we're subtracting, so you can add the opposites there. Some of these don't have like terms, so you can just bring them down. And then, so x cubed minus 3x minus 7, or plus negative 7. And then if we look over here, they want us to name these polynomials based on their degree and number of terms. Make sure it's in standard form first, and make sure there's no like terms that you could combine. And so it looks like we're ready to go here. So this one, since the highest exponent is 2, that means it is quadratic. And there are 3 terms, which means it's a trinomial. And then number 6, highest exponent is 1, which we don't really see, but that makes it linear. And there's 2 terms, would be binomial. So linear binomial. So this gives you an idea of how to add and subtract polynomials. Have a good day.